Okay, we're going to solve a problem that involves compound interest. We've got a principal investment of $100, initial investment. We are going to keep it in the bank for 1 year. It earns a rate of return of 5%. It's compounded monthly, which means n equals 12. And this is our formula. So we'll put in all the information that we know. We have 100 times 1 plus the rate is 5%. So we have to put to 0.05 divided by 12 to the 12 times 1. And that will help us calculate the amount of money that's in the bank after, or in this account, after 1 year. So at this stage I'm going to take a calculator to type this in. 100 times 1 plus 0.05 divided by 12. I'm going to take that to the power, and I'm going to hold that as the exponent of 12 times 1. We end up with $105, which would be simple interest, but because it's compounded monthly, we get a few more cents, 12 cents, 11.6 cents, we'll round to there. And I was thinking about this question. We could also expand and say, well, what happens if we want to know in general how long would it take for an investment to, let's say, double in value if it earns a return of 5%, compounded. This time we'll just, to mix up, we'll say continuously. So now our formula is A equals P times E to the RT for continuous compounding. The amount and the P, that's the thing, we don't know. But we do know that if we start with P, we eventually want to get to double. So we want to get to 2 times P. So the amount that we finish with, we're trying to get to is 2P. We don't know the initial investment. E is the natural number when you're compounding continuously. The rate is 5%. And time is the question. How long will it take? I should have a question mark there. So this at first glance has 2 variables, or 2 unknowns I should say, but assuming this principal is positive number, well, we can just divide both sides of the equation by P and they cancel out. So this equation now becomes 2 equals E to the 0.05 T. Now we've got an unknown as an exponent. We can take the natural log of both sides of the equation, or conversely, you can just convert from an exponential to a logarithmic equation and say, okay, this is the same thing as saying the natural log of 2 is equal to 0.05 t, which is what's going to happen here. And the natural log of e is, of course, 1. So we've got this equation here. The natural log of 2 equals 0.05 t divided by 0.05. And we have the natural log of 2 divided by 0.05 equals t. This is how long it's going to take for the investment to double. So I'll type this in now to get an approximate number here. Natural log of 2 divided by 0.05, and we end up with 13.9 9 years would be how long it takes for the principal investment to double. Notice that this is independent of whatever P is. P could be $100, like on our initial example, or it could be $1. We want to know what happens, how long it's going to take for it to double.